The HP 49 and 50 series calculators support reverse Polish Lisp RPL programming like the HP 48 series before it. The standard user accessible RPL is a small subset of a much larger, richer RPL language, which the calculator's operating system is written in. To distinguish between these two versions of RPL, the standard user accessible RPL is called user RPL and the richer superset is called System RPL or Sys RPL. Whereas the HP 48 series required third-party tools to access System RPL, the HP 49 and 50 series supports it natively, as well as machine code. However, it is not enabled by default. This video shows how to enable and test Sys RPL on the HP 50G calculator. The calculator is already configured in RPN mode with soft menus enabled. 3 libraries are required to enable Sys RPL programming. Library 256 contains a number of tools for development, including the disassembler and a front end for the compiler, and is built into the calculator. Library 257, MASD, contains the machine language and System RPL compiler, and is also built into the calculator. Library 258, XTable, includes all Sys RPL entry points and addresses, and is necessary to program using Sys RPL keywords, and also for the disassembler to work. This library must be loaded into the calculator. See the description for a link to download the XTable library. Transfer xtable.hp to the calculator via SD card or USB and store in port 2 as shown. Go to Files, go to the SD card, locate XTable, recall it. There's the library, store it in port 2. Now attach library 258, 257 and 256. Attach 257, attach 256, attach. Once the libraries are attached, a warm start or power cycle is required. So I've just warm started the calculator. A number of system flags are also used to configure the calculator for SysRPL programming. Flag -92 controls the compiler default mode. Setting the flag enables SysRPL programming by default. It is also possible to switch modes with directives if you need to change from your default, example, to machine code. Flag -85 enables the System RPL Stack feature, which disassembles stack objects before displaying them. This lets you see the code in the object instead of a lot of external references. So we'll set flag 92, system flag 92, to enable SysRPL by default. A simple SysRPL program will now be used to demonstrate that configuration is working. A SysRPL program is entered into a string and contained within the start and end of secondary, i.e. program markers, colon, and semicolon respectively. To be recognised by the compiler, the program must end with the @ character. A program to sum squares has already been entered as shown. You can see the string with the start and end program, colon, and semicolon. You can see the end of code marker, the @ symbol. The program contains a loop from 1 to the number entered plus 1, and it sums the squares as it repeats the loop until finished. To compile the program, go to the Development Tools menu with Apps. Scroll up and select Development Lib. If all the libraries are attached correctly, you'll now have a menu of development tools. Go next 5 times, and then we can see the compiler as the first menu entry there. Compile the SysRPL program, and we can see the program there. We know it's SysRPL because there's a lot of externals listed, as by default SysRPL is not decompiled and displayed. Setting the system flag 85 will enable the System RPL stack and decompile the program before display, providing a more practical view of SysRPL programs. So we set that flag now. We'll see the compile program displayed with the code. The program can be evaluated as is or saved and executed as shown. So we'll save the program. Enter a value for the number of squares to sum and then execute the saved program. Note, no error checking has been included in this program, so the number entered must be a real, so must finish with a decimal point. So we can see there that the result has been displayed. System RPL provides lower level access to the calculator. There are thousands of additional functions available when using System RPL. As error checking is limited and dependent on the programmer including it, System RPL runs faster than User RPL. See the description for links to the Xtable library download and SysRPL and MASD documentation.